Whoa. Okay. Take 3. Okay, this is the answer key for the equivalent resistance worksheet. We take a look at number 1. We leave the battery here. We start current leaves the battery, and it flows right into a 6, then into a 2, and then to a 4 ohm resistor, and goes back to the battery. There's only one path there. That is definitely a series circuit. Series circuits, we just added up. So it's 6, 2, and 4, and that one is 12 ohms. Pretty simple. Over here for number 2, it is the same resistors. It is a 6, 4, and a 2, but now it's all in parallel. If you take a look at the battery pack, we leave the battery pack and the wire splits. Current can either flow down this branch, flow towards this next one. Some of it will go down this branch, and then the least amount of it will make it down to the end here. Not because it's on the end, but it has the most resistance. But current will be split here. So we'd have to add this up with the reciprocal method. So let me do that here. So 1 over what we're looking for is 1 over 6, 4, and 2. 1 over 6 plus 1 over 4 plus 1 over 2. Let me see if I can just do that with common denominator. So we've got 2 twelfths. We've got, 3 twelfths. And we've got 6 twelfths. The heck is that? 9, 11 twelfths. That's 12. When we flip it over, we get 12 elevenths. What is 12 elevenths? Let me see. 1.09 ohms. The way you do that in a calculator, let's just double check it with the calculator. We do 6 to the negative 1 plus 4 to the negative 1 plus 2 to the negative 1. Answer, flip it. Yes, that is the answer. Cool. So purely parallel, all in parallel with each other. Looking at number 3 over here, we got a mixed circuit going on. So current leaves the battery. Again, I tend to go clockwise. It doesn't really matter. You need to figure out the resistance. What's going on here? We leave the battery, and I see the wire splits. But then it comes back together, and then the current would flow. All of it would flow through this third one there. So these 3 are not all in parallel with each other. These 2 are in parallel with each other, and then those 2 are in series with this final one. So we'd have to add up the 4 and the 8 in parallel, and then we'd have to add up whatever that's equivalent to the 2. Let me... Oh. Okay, so a 4 and an 8. So we'd have to do the reciprocal method because it's in parallel. We'd say 1 over 4 plus 1 over 8. What the heck is that? So that's 2 eighths, 3 eighths, 8 thirds when you flip it over. So 8 thirds when you flip it over. 8 divided by 3. Answer is 2.67. 2.67 ohms. Let's just double check real quick with the calculator. And it's 4x to the negative 1 plus 8x to the negative 1 equals, but then flip that, and 2.67. Cool. Moving on to the 4th one here. I see another complex circuit. Take a look. We leave the battery going clockwise, and the wire splits. So there's 2 parallel branches, and then it comes back together. But if you look in this first parallel branch, there is a 6 and a 4 in series with each other. So you just need to be careful. Hunter, did you just fall down? Oh. Okay, I'm going to keep recording. So, okay. Current leaves the battery here because it's my 3rd attempt at this. Current leaves the battery, and it has to then, once again, there's 2 choices. These 2 branches are in parallel with each other. And you'd have to add these up in series with each other. So this first upper branch here is a 6 and a 4 in series. So this would be 10. So then it's a 10 in parallel with a 5. So again, this is not a 4, 6, and 5 all in parallel with each other. It's a 4 and 6 in series, and then that is in parallel with the 5. So we'd say 4 and 6 in series is 10. So it's a 10 and a 5 in parallel. 10 and a 5 in parallel. So 1 over 10 plus 1 over 5. So what is that? That's 3/10, 10 thirds. Whatever that is, 10 thirds ohms altogether. Let's take a look at number 5. Oh boy. All right, what do we got going on here? We leave the battery, we go right through a 2, and then I see a split. and then I see it coming back together, and then I see it going through the 6. So it looks like we have this in series with a parallel section, and then that in series with a 6. So what I'd want to do first is figure out what is a 5 and a 15 in parallel. A 5 and a 15 in parallel. 1 over 5 plus 1 over 15. So what is that? Oh, 1 over 15. So what is that? 3/15, 4/15, 15/4 would be your resistance. What is that? 15 divided by 4. 3.75. Now that's the equivalent resistance of the 5 and the 15. You know what? Just so I don't look stupid, let me double check that. 5x to the negative 1 plus 15x to the negative 1. And then flip it. Yeah, 3.75. And then what we're left with then is we know the equivalence of this section, 3.75. And then we just add 2 and 6 and 3.75 together. What is that? 8. Was that 11.75? I hope. Check my quick maths. Number six. Whoa, what do we got going on there? It looks like just 4 resistors all in parallel with each other. Nothing is going one into the next. Everybody is touching both sides of this battery. This is 4 things all in parallel. So let's just figure that one out. 4 things in parallel. We need our reciprocal formula. So 1 over 8, 1 over 4, 1 over 2, 1 over 4. So 1 over 8 plus 1 over 4 plus 1 over 2 plus 1 over 4. And you add that all up, common denominators. So we got 1/8, we've got 2/8, we got 4/8, and we've got 2/8 again, 2/8. What is that? That's 9/8. So it's 8/9. When you flip it over, total resistance, 8/9, whatever that is. 8 divided by 9, 0.89 ohms. Cool. Ask any questions in the chat. See you later.